something just hit the moon. A sudden flash, brief, silent, and unmistakable. It lasted less than a second, but it was real, and it was seen live. No explosion, no warning, just a momentary burst of light on the moon's dark surface that instantly caught astronomers off guard, because impacts like this are rarely witnessed in real time. And this one may be tied to something far larger moving through space right now. Earlier this month, astronomers recorded a brief but unmistakable flash of light on the moon. It appeared suddenly, lasted less than a second, and then vanished, leaving behind more questions than answers. This flash was the result of a small space object striking the lunar surface at extreme speed, releasing a burst of energy visible from Earth. What makes this event extraordinary is how it was captured. Unlike most lunar impact flashes, which are discovered later through automated software or careful frame-by-frame analysis, this one was seen live. A ground-based robotic telescope, routinely monitoring the moon, caught the flash as it happened. The observer noticed it instantly on screen, an experience so rare that many veteran lunar observers never witnessed one in their entire careers. The timing played a critical role. The impact occurred during the moon's new phase, when much of its surface was unlit by the sun. Against this dark background, even a split-second flash can stand out clearly. If the same impact had occurred on the sunlit side, it would have been completely invisible from Earth. Early analysis suggests the object responsible was extremely small, likely only a few centimeters across, but size can be deceiving in space. Traveling at tens of kilometers per second, even a tiny fragment carries immense kinetic energy. When it collided with the moon's airless surface, that energy was instantly converted into heat and light, producing the flash that caught astronomers by surprise. This single moment, barely visible to the eye, marked a rare real-time glimpse into an ongoing and invisible process shaping the moon every day. Although the impact itself was small, events like this carry significant scientific value. Lunar impact flashes provide rare, direct evidence of how frequently small objects collide with the moon, information that is surprisingly difficult to obtain through other methods. Unlike Earth, the moon has no atmosphere to slow down or burn up incoming debris. Objects of all sizes strike its surface directly, preserving the raw physics of the collision. When a meteoroid hits the moon at extreme speed, its kinetic energy is rapidly converted into heat and light. This produces a brief optical flash that can be measured and analyzed. By studying the brightness and duration of that flash, scientists can estimate how much energy was released and infer key properties of the object, including its approximate size and velocity. Over time, combining data from many such events allows researchers to refine models of the small object population moving through near-Earth space. These models are essential for understanding how debris circulates throughout the inner solar system and how often planetary bodies are struck by unseen particles. The timing of this particular impact is especially important. It occurred during the active period of the Geminid meteor shower, one of the most intense and reliable annual meteor showers observed from Earth. The Geminids are known for producing fast, bright meteors, but their origin makes them unusual. Instead of coming from a traditional icy comet, the stream is linked to a rocky object called 3200 Phaethon, which sheds debris as it passes close to the sun. Earth is not the only body that passes through this debris stream. The moon regularly crosses the same region of space, making impacts like this not only possible, but expected. Preliminary estimates suggest an impact speed of around 35 kilometers per second, consistent with Geminid debris. This single flash helps confirm long-standing predictions and reveals just how active the space around the moon truly is. While the timing and speed strongly suggest a connection to the Geminid meteor stream, scientists are careful not to jump to conclusions. Identifying the exact origin of a lunar impactor is complex. Researchers must consider viewing geometry, timing precision, and instrumental limitations before drawing firm conclusions. Still, the evidence in this case points in a compelling direction. The estimated velocity of the object, around 35 kilometers per second, matches well with typical Geminid meteoroids. Combined with the fact that the impact occurred during the peak activity window of the Geminid shower, the probability of a connection is difficult to ignore. While this does not conclusively prove the object came from that stream, it significantly strengthens the case. Events like this help validate long-standing theoretical predictions. Scientists have long believed that meteor streams impacting Earth should also strike the moon, but direct observational confirmation has been limited. Each verified flash provides real-world data that helps bridge theory and observation. Importantly, this observation also helps constrain the lower end of the meteoroid size distribution. Large impacts are rare and well studied, but small impacts are far more common and far harder to detect. Each confirmed detection improves estimates of how often these tiny yet energetic collisions occur. Though invisible to most observers, these constant impacts quietly shape the moon's surface over time, contributing to its heavily cratered appearance and reminding us that the lunar environment is anything but static. Beyond its scientific value, this lunar impact carries important practical implications, especially as humanity prepares for a long-term return to the moon. Future missions aim to establish sustained lunar infrastructure, including habitats, power systems, scientific instruments, and communication networks. Even impacts from very small objects can pose cumulative risks to exposed equipment over time. Unlike Earth, the moon has no atmosphere to provide protection. Every fragment of debris, no matter how small, strikes the surface at full cosmic speed. Understanding how often these impacts occur and with what energies is essential for designing shielding, placement strategies, and long-term durability for future lunar systems. This event also highlights the growing importance of continuous lunar monitoring. Advances in imaging technology, automated detection software, and coordinated observing networks are making real-time detection of impact flashes increasingly feasible. What was once a rare and lucky observation may soon become routine as monitoring capabilities improve. There is also the potential for follow-up observations from lunar orbit. In some cases, high-resolution images captured by orbiting spacecraft can reveal fresh impact craters that correspond to observed flashes. Even when no visible crater is found, that absence still provides valuable constraints on impact size and energy, helping refine scientific models. From a research perspective, lunar impacts act as natural experiments. Each collision excavates material from beneath the surface, briefly exposing subsurface layers to the harsh space environment. Studying these processes offers insight into how the moon's surface evolves over time and how it responds to constant bombardment. On a broader scale, events like this reveal the dynamic nature of the Earth-Moon system. The moon is not a silent, inactive world. It is constantly interacting with streams of debris that also produce meteor showers on Earth. As monitoring improves, scientists may increasingly be able to link individual lunar impacts to specific meteor streams, allowing more precise mapping of debris populations throughout near-Earth space. That brief flash on the moon was more than a fleeting spectacle. It was a rare, real-time glimpse into an ongoing process that usually unfolds in silence and darkness. For less than a second, an invisible collision became visible, confirming that the moon is still being shaped by constant impacts from debris moving through the inner solar system. Events like this remind us that the moon is not a static relic of the past. It is an active world, continually interacting with the same streams of material that create meteor showers on Earth. While most of these impacts go unnoticed, each one contributes to the moon's evolving surface and adds another data point to our understanding of the space environment around our planet. As monitoring technology improves, moments like this may shift from rare surprises to valuable scientific observations. Networks of automated telescopes combined with advanced software and orbital imaging are making it possible to detect and analyze these events with increasing precision. What once required luck and timing may soon become part of routine lunar observation. In the long term, systematic monitoring of lunar impacts could play a role in planetary defense research. While small objects pose little direct threat to Earth, understanding how debris behaves in near-Earth space is essential for assessing larger risks. The moon, in this sense, serves as a natural detector, quietly recording the passage of objects that pass close to our world. But perhaps the most striking aspect of this event is how it was seen. Not predicted, not reconstructed later, seen live. A reminder that even our closest celestial neighbor still has the power to surprise us. If you found this moment as fascinating as scientists did, consider subscribing for more real-time discoveries and hidden events unfolding across our solar system.